Hi friends, welcome to Spectrum Academy. Today I am going to talk about basics required to solve the problems in Fourier series. We required strong foundation of integration. But generally when we think of integration we get scared because there are a lot of formulae and a lot of theorems to remember. However, I have listed down few formulae and few theorems essential for solving problems in Fourier series. So if you master these few selected formulae, you will be absolutely good in Fourier series. Let's look at those formulae. Integral x raised to n dx is x raised to n plus 1 upon n plus 1 plus c. This formula not to be used for n equal to minus 1. Next, integral sine ax dx equal to minus cos ax divided by a, where remember this a is the coefficient of x. Next, integral cos ax dx equal to sine ax upon a. Once again, this a is nothing but coefficient of x. Now look at these two big ones. Integral e raised to ax sine bx equal to e raised to ax divided by a square plus b square into a sine bx minus b cos bx. Next one, e raised to ax cos bx dx equal to, see this outside term is same, e raised to ax divided by a square plus b square into a cos bx plus b sin bx. Apart from this, please remember this very useful formula. Sine of n pi is always 0, where n can be any integer. So sine 1 pi, sine 2 pi, sine 3 pi, sine 4 pi, sine 5 pi, all values are equal to 0. Cos n pi equals to minus 1 raised to n. This n can be either odd number or even number. So if n is odd integer, for example, cos 1 pi, cos 3 pi, cos 5 pi, it is going to be minus 1. And if this n is even integer, then cos of say 2 pi, 4 pi, 6 pi, all that is going to be 1. So remember this basics, very useful. Next, these 4 defactorization formulae, to remember you studied in 11th standard somewhere in trigonometry. So sin a cos b is half sin a plus b plus sin a minus b. Similarly, cos a sin b, the difference is just of minus sign. Cos a cos b is 1 by 2 cos a plus b plus cos a minus b. And sin a sin b is 1 by 2 cos a minus b minus cos a plus b. A theorem from integral minus a to a fx dx. Look at the limits, very interesting. Minus a to a, they are opposite of each other. Limits are opposite of each other. So minus a to a fx dx equal to 0. The answer for this integral is straight away 0, provided the function is an odd function. Otherwise it is 2 times integral 0 to a fx dx. In this case the function must be even function. Now we are going to talk about odd function and even function. Let's now try to understand what are odd function and even function using one example. Consider a function sin x and consider a function cos x. And I want to know whether the function is odd or function is even. So what is the method? In place of x, you write minus x. If you want to check whether function is even or odd, the procedure is in place of x, you write minus x and then see what happens. Sine of minus x gives this minus sign out and cos of minus x absorbs that minus sign. So here f of minus x is minus of sine x. That means f of minus x is negative of the original function. And here f of minus x is cos x. That means f of minus x is same as the original function. So here f of minus x is same as f of x and f of minus x is same as negative of f of x. So when you replace x by minus x, and you get negative of the original function, it is odd function. And when you replace x by minus x and you get exactly the same function, it is even function. Next, when we have one odd function multiplied with another odd function, remember the answer will be even function. When you have one odd and one even function multiplied, answer will always be odd function. Even function into even function is going to be even function. For example, x raised to 3 is an odd function and sine of x is also odd function. So x cube into sine x, this is also going to be an odd function. Hope things are clear. So if you remember these basics of integration, few basics of trigonometry, which I already told you, your Fourier series is going to be absolutely strong. Now next lecture will be on Fourier series. Stay tuned. Goodbye. Good luck. See you later.